Hello and welcome to another video brought to you by Cyberlink UCAM, because it's the only thing that I can record my screen with. Now today we'll be talking about outputs of a computer, and this will be basically mained on audio and visual. Now, we first start off with a CRT monitor. A CRT monitor displays text and image data passed to it by the computer. The CRT in CRT monitor stands for cathode ray tube, and the CRT monitor is the type that has been around for years and is large and boxy, as you can see from the picture. CRT monitors are heavy and they take up a lot of desk space. They have largely been replaced by flat screen monitors. However, some are still used in the design industry since the color accuracy and brightness of the CRT monitors is excellent and designers need to see true to life colors. Also, CRT monitors are generally cheaper than flat screen monitors. Next we have flat screen monitors, also known as TFT or LCD. TFT and LCD are two of the technologies used in flat screen monitors. TFT is thin film transistor and LCD is liquid crystal display. Another technology that may replace these is OLED, or organic light emitting diodes. Over the past few years, as they have come down in price, flat screen displays have replaced CRT monitors. Flat screen monitors are light in weight and they take up very little desk space. Modern flat screen monitors have a good quality picture that is as good as the CRT monitors. Next we go on to digital multimedia projectors. Digital projectors are used in situations when a very large viewing area is required. For example, during presentations, for advertising, or in your home for watching movies. A projector connects to a computer, a DVD player, or a satellite receiver, just like an ordinary monitor. The image is produced inside the device and then projected out through a large lens using a powerful light source. This can also project out your computer screen, so when if you want to use your computer in a much larger screen to show other people, then you can use this. Next, we have a loudspeaker. If you want to hear music or sound from your computer, you will have to attach loudspeakers. They convert electrical signals into sound waves. Loudspeakers are essential for applications such as music editing, video conferences, watching movies, etc. But nowadays you would have desktop computers which normally or sometimes have built-in speakers. We then have dot matrix printer. No, not that kind of matrix, this kind of matrix. If you want a physical copy of some data on paper, or a hard copy, you'll need a device that can make marks on paper, a printer or a plotter. Now, a dot matrix printer is named after the pattern, a grid or matrix, of dots used when creating the paper printout. These dots are formed by tiny pins in the printer's printhead that hit an inked ribbon against the paper, leaving marks. As the printhead moves along, it leaves a pattern of dots behind it which can form letters or images, or etc. Dot matrix printers often use continuous stationery, long continuous strips of paper rather than separate sheets of A4, and after printing the printout is torn off from the long strip. Dot matrix print quality is poor, the printers are noisy, and there are much better printing systems available today. However, the dot matrix printers are still used in such situations. Since the pins actually hit the paper, several carbon copies can be printed in one go. An example of this is airline tickets, which have several duplicate pages, all printed in one go. The print mechanism is very cheap and the inked ribbons last for a long time. So, where cheap, low-quality printouts are required, dot matrix printers are used. An example is a shop receipt. Next we have inkjet printers. Cheap, high-quality, full-color printing became available during the 1980s due to the development of these inkjet printers. These printers have similar printhead mechanism to a dot matrix printer. The printhead passes left and right across the paper. However, instead of using pins to hit inky marks onto the paper, the inkjet squirts tiny droplets of ink onto the surface of the paper. Several colored inks can be used to produce full-color printouts. The droplets of ink come from tiny holes which are less than a width of a human hair in size. Each droplet creates a tiny dot on the paper. Since the dots are so small, the quality of the printout is excellent. This is perfect for photographs. Inkjet printers are very quiet in use. Since they have so few moving parts, they are also cheap to manufacture and thus cheap to purchase. However, the ink is very expensive to buy, which is how the companies make their profits, so the printers are very expensive to use. Next, we have laser printers. Once again, not really what I'm talking about, more about this. Laser printers are very complex devices and thus expensive to buy. However, they are very cheap to use. This is because they produce marks on paper using a fine dust called toner, which is relatively cheap to buy. The laser printer uses a complex system involving a laser to make the toner stick to the required parts of the paper. This system is very different to a dot matrix or inkjet, and you don't need to know the details about it. The laser and toner systems allow very fast printing compared to other printers, and laser printers are very common in offices since they print very quickly and are cheap to use and are reasonably quiet. We then have a plotter. Plotters create hard copy in very different ways to printers. Instead of building up text and images from tiny dots, plotters draw on the paper using a pen. The pens are held in an arm which can lift the pen up or down and which can move across the paper. The arm and pen create a drawing just like a human could, but much more accurately and more quickly. Different color pens can be used to produce colored line drawings. Plotters are often used by designers and architects since they work with huge pieces of paper, far bigger than anything a normal printer could work with. But plotters are only suitable for producing line drawings. They cannot produce the kind of text and images that an inkjet or a laser printer could, so you cannot use a plotter to produce photos, for example. Now we move on to actuators. Now, an actuator is a device controlled by a computer that can affect the real world. Examples of these actuators in the real world are light bulbs and LEDs which can create light, heaters that increase temperature, cooling units that can decrease the temperature, motors that spin things around, pump that pushes water and air through pipes, and buzzers, bells, sirens that create noise. Actuators are used extensively in computer control systems. Of these actuators, we have motors and parts. Motors can provide movement. For example, the motor in a washing machine can be controlled by a computer. It is switched on when the clothes are loaded for washing and switched off at the end of the wash. Computer-controlled motors are also found in microwave ovens to turn on the food and air conditioning units to drive the fan. A pump is basically a motor attached to a device that can push water or air along pipes. When the motor is switched on, water or air flows along the pipes to places it is needed. Pumps are used in many places as part of watering systems in greenhouses, in factories, and other main factorized areas. Next, we have buzzers and lights. Buzzers can provide noise. For example, the buzzer in a microwave oven can be switched on by the controlling computer when the food is cooked. Louder noises can be made using a siren or an electric bell, for example in a burglar alarm system. Light bulbs and LEDs can be used to provide light or to indicate something. For example, computer-controlled lights are used in traffic lights, at music concerts, and in speedometers in cars. Lights are also then used in car dashboards to show if there are any systems in the car that have problems. Finally, we move on to heaters and coolers. Heaters can provide heat and coolers can cool things down, which is kind of in their name. A computer can switch a heater on or off when needed to keep a room or a greenhouse at the correct temperature during winter. A computer can also switch a cooling unit on or off to keep a room at the correct temperature during hot weather or to keep food fresh. Now, we move on to quiz. I did tell you to pay attention. Now, what does a CRT stand for in a CRT monitor? Now, you have 15 seconds to answer these questions, and for each question, I will show you 15 seconds of a dog dancing to the south. What does CRT stand for? It stands for cathode ray tube. Next one. What does LCD stand for? I told you to pay attention. Once again, here's 15 seconds of a dancing doll. An LCD stands for liquid crystal display. Next one, how does a dot matrix printer work? Is it A, formed by tiny pins in the printer's print head that hit an inked ribbon against the paper leaving marks? B, formed by tiny pins in the printer's print head that hit a hole into the paper's leaving holes? Or C, unicorns? The answer is A, which is formed by tiny pins in the printer's print head that hit an inked ribbon against the paper leaving marks. If you guess C, you may want to rethink your choice of going for a GCSE in computer science. Now, for the last question, when lights and buzzers like the horn and the speedometer in a car are being used, what controls them? A, artificial intelligence used in fighter drones, B, a computer, or C, rigid hammered with a couple of levers. Once again, 15 seconds of an awesome doll. And the answer is B, a computer. Thanks for watching this video on outputs of a computer. Check how many questions you got right out of 4, and please leave your marks in the comments below. This has been Outputs at the Finest. I'll see you later.